Hi, hello, welcome to Mathsmedium. Today I came with a topic that is properties of a square number, some more interesting patterns of a square from Squares and Square Roots 8th class NCERT. Now coming to the table, this is the table about the properties of a square numbers. These are the numbers here 1, 2, 3, 4 up to 20. These are the square numbers according to the 1 to 20 numbers. We have to study this table and I will explain through this table how square numbers can get easily by observing the given number. See here 1, 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25. Similarly up to 20 we have 400. If you check unit digit place, it means ones place. Here we get 1, 4 and 9, 6, 5. Again we get 6 here. Again we get 9. Again we get 4. Again we get 1. Here we have to add 0. Next here 11 and we get 121. It is 1, 144, 4. Again in ones place we get 9, 6, 5. 6, 9, 4, 1, 0. If you observe this table, we get only these 6 numbers as the ones place. If you take any number, it must be having unit digit as these numbers. If you start with any number, there is a ones place with 0, 1, 4, 5, 6, 9. None of the numbers, it means 2, 3 and 7, 8. These are the digits. None of the square can be formed. Because if you observe these patterns, we get only 0, 1, 4, 9, 6, 5 at ones place. But none of the number get the 2, 3, 7, 8 as a ones place. So this is the best property of a square numbers. By observing the ones place, we can estimate it as a square number that is also perfect square. That means these 6 numbers, if in case in ones place, then we will find the square number easily. Next, coming to the some more interesting patterns of a square. In earlier session, we already discussed about the some more interesting patterns of a square. Those are 1. Adding triangle numbers. Here we know that triangle numbers. Do you remember the triangle numbers? Let us recall 1 representing as like this. Next to 3 representing like a triangle. See this? This is a way of triangle. And next coming to the 6. 1, 2 and 3, 4, 5 and finally we get 6. This is also a triangular number. Next coming to the 10, we get 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. This is the triangular numbers. And next 15 and some are there. But now coming to here, adding triangle numbers. If you use 1 plus 3, 1 plus 3, how we get 4? It must be like 1, 2 and 3 and this is the 1. This is the one triangle and this is the 1. How we can represent it as 2 square, right? If we add 3 and 6, how will we get 1, 2, 3, 4, 5, 6, 3, 1, 2, 3. We get 9. It means 3 plus 6. Here 3 plus 6 is equal to 9. It means 3 square. If you add 6 plus 10, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Add this 6 to this 10. 1, 2 and 3, 4, 5, 6. Here 10 plus 6 is equal to 16. It means it is a 4 square. Here we can observe one thing. Adding triangular numbers, it means by using 2 consecutive triangle numbers, by adding 2 consecutive triangle numbers, we got a perfect square number. That is the main thing here. That is, if we sum up the two consecutive triangular numbers, we get results as a square number. This is the one of the best property of a square number. See, if you add these consecutive triangle numbers, then we will get perfect square. Next, coming to here, numbers between square numbers. See, 1 square is equal to 1, 2 square is equal to 4, 3 square is equal to 9, 4 square is equal to 16, 5 square is equal to 25. I am using these squares for this example because of it is easy to understand, right? So if you compare here, 1 square it means 1, 2 square it get 4, between these two we get 2, 3, two numbers are there. Next, coming to here, 2 square, 3 square, it 4 and this is 9. Here we get 5, 6, 7, 8. We get 4 numbers. Here we get 2 numbers as the result. If you compare 4 square and 5 square, 16 and 25, 17, 18, 19, 20, 21, 22, 23, 24 as the between numbers of these two squares. Here we get 1, 2, 3, 4, 5, 6, 7, 8. 8 numbers as the. If you prolong this, 6 square is equal to 36, 7 square is equal to 49. These two between, how many numbers are there? In any case, we can solve this as 2, 4, 8. If in case bigger numbers are there, how can we find the numbers between the square numbers? There is a simple formula for this. Let it be, this is n square and this is n plus 1 square. How it must be? If you take here 1 square, this is 1 plus 1 square. If you check this, 3 as a n and n square means 3 square, n plus 1 square, it means 3 plus 1, it get 4 square, right? If the numbers is n square and n plus 1 square, the result is n plus 1 whole square minus n square is equal to, if you solve this, we get the problem like 2n 1 plus 1. If you check this, n square plus 2n plus n, 1 minus n square cancel, here 2n plus 1 as the answer. So if you take any number, here 2n plus 1, if you apply this to this, n means 1, right? So 2 into 1 plus 1, 3 plus 1, we get 4. Sorry, 2 into 1, 2, 2 plus 1 as equal to 3. Here we get 3, but here is 2. That is the trick here to know, that is non-square numbers between two square numbers, that means n square, n plus 1 square, we get 2n plus 1, but it is 1 less than the difference of two squares. I will explain you clearly. See, here we get n square and n plus 1 square, but how we are going to write n plus 1 square minus n square? Here the difference of two squares, it is equal to the 1 less than the difference of two squares. We get 2n plus 1 minus 1. In this case, minus 1 cancel, we get 2n. This is the answer for to find the numbers between a square numbers. Those are non-square numbers. Next, third one is sum of consecutive natural numbers. Here, by using consecutive natural numbers, that is the sum of consecutive natural numbers, we can get a square. That is, we have to prove here. See, if you take 3 square 5 square, 7 square, 9 square, 11 square, etc. How can be written as 3 square 9, 5 square 25, 7 square 49, 9 square 81, 11 square as 121. Now, by using two consecutive natural numbers, by adding their by sum of the two consecutive natural numbers, we get the answer. If you check, this is represent as 4 plus 5. Next, 25 as 12 plus 13. If you represent 49 as 24 plus 25. If you represent 81 as 40 plus 41. Similarly, 121 as the 60 plus 61. See, 4, 5, 12, 13, 24, 25, 40, 41, 60, 61. By observing these, we get one formula, that is n square minus 1 by 2 plus n square plus 1 by 2. This is the formula to get the sum of consecutive natural numbers. If you check this, let it be n as 3. N is equal to 3. How we are going to get n square? 3 square minus 1 by 2 plus 3 square plus 1 by 2. Here 3 square minus 1, we get 3 square 9 minus 1 by 2 plus 9 plus 1 by 2. 9 minus 1, we get 8 by 2 plus 10 by 2. 2 ones are 2 fours are 2 ones are 2 fives are. Here 4 plus 5, it gives you 9, that is as 3 square. This is the what we have to prove. If you take another number randomly, let's take 7 as the n, that is 7. How it can be? 7 square minus 1 by 2 plus 7 square plus 1 by 2. 49 minus 1 by 2 plus 49 plus 1 by 2. Here 49 minus 1, 48 by 2 plus 50 by 2. 2 ones are 2 twos are 4, 2 fours are 8. 2 ones are 2, 2 25s are 24 plus 25 is equal to 49, that is 7 square. This is the n we chosen. This is the two numbers we are adding. This is the result what we have to do. This is about the sum of the consecutive natural numbers. Next, coming to the fourth one, adding odd numbers. By using adding odd numbers, we get a square. This is also another property of a squares. Let's consider taking odd numbers from 1. So, odd numbers, we know that 1, 3, 5, 7, 9, 11, 13 and so on. By using odd numbers addition, we get a square number. How it can be? See, 1 odd number, it is get 1 square, that is 1. If you see, by adding two odd numbers, it means 1 plus 3, 2 odd. 4, it means 2 square, it is 4. If you take 1 plus 3 plus 5 up to here 5, it gets 3 odd numbers, right? So now how we are getting 5, 3, 1, it means 9. 3 square is equal to 9. Similarly, 1, 3, 5, 7. 1 plus 3 plus 5 plus 7. Here we have 4 odd numbers. It means 4 square. We get 16. 7 plus 3, 10. 15, 16. Similarly, 1 plus 3 plus 5 plus 7 plus 9. 1, 2, 3, 4, 5. 5 odd numbers. Here we get 5 square as the answer. It is 25. 9 plus 1, 10. 15, 25. See, if you observe these 5 patterns, example, 1 odd number, it means 1 square. 2 odd numbers, it is 2 squares. 3 odd numbers, 3 square. 4 odd numbers, 4 square. Here, how many odd numbers are we are adding? That is equal to the that much square number. 5 odd numbers, 5 square, that is 25. If you take 6 odd numbers, it is must be as 36. Check it. 1 plus 3 plus 5 plus 7 plus 9 plus 11. It is 6 odd numbers. Obviously 6 is square. But apart from this, 11 plus 9, 20. 20 plus 10, 30, 36. It is right? So this is the property of adding odd numbers. How we can written it as, if the number is a square number, it has to be the sum of successive odd numbers starting from 1. This is the property adding odd numbers. Next, finally, product of two consecutive even or odd natural numbers. Here in case of product of natural numbers, that is also two consecutive even or odd, anything. So if you take as example, 11 into 13 is equal to 143. How we can represent it as 12 square minus 1. Here 12 square minus 1 written as 12 square minus 1 square. It is in the form of a square minus b square. The answer is a plus b into a minus b. So it can be written as 12 minus 1 into 12 plus 1 as the answer. Similarly, if you take any two numbers like 13 into 15, two consecutive odd numbers these are also. Let's take here 14 minus 1 into 14 plus 1. It's like 14 square minus 1. If you take even numbers like 44 into 46, how it can be written as 45 minus 1 into 45 plus 1. It is as 45 square minus 1. In generally, we can say it as a plus b into a minus b, that is equal to a square minus b square. This is the form of the product of two consecutive even or odd numbers, that is also natural numbers, to get a perfect square. These are the basic properties and interesting facts about the squares. There are so many ways to project a square number by using natural numbers, odd numbers, even numbers, product or sum or subtraction. These are the basic things. I hope you understand about this session. If you have any doubts, comment on the comment box, click like button and share my videos and subscribe my channel. Thank you.